Hello everyone. Today today's class we will discuss about the half-life of a chemical reactions. Now, what is the meaning of this term is half-life? Half means half, okay, 1 by 2. Life means for the complete occurrence of complete for the completion of reactions. And so the half-life defines the time required to complete half of a chemical reaction simply. Okay, now it is defined as the time in which the concentration of the reactant reduces to one half of its initial concentration. That means, simple word, the half life is of a reaction is the time which is needed for the completion of half of the reaction. That means, to become the concentration of the reactants half. Okay, now see what is the chemical reaction, what is the equation or relationship of half-life period. Now see, for the zero order reactions, if or when t becomes t half, that means time of a reaction becomes t half, then obviously the concentration of the reactants become obviously half. Okay, okay, the concentration of reactant becomes the concentration of R naught by 2. R naught is the initial concentrations. Okay, initial concentration, that's why I'm writing here initial concentrations. Now, as we know, for the zero order reactions, K equal to R naught minus R divided by T. It becomes, that means the substituting the T half in place of T and R naught by 2 in place of concentration of R. We get K equal to concentration of R naught minus concentration of R naught divided by 2. Okay, and in place of T, T half will be written. Okay, next, if you just simplify, we'll get T half equal to R naught divided by 2K. R naught divided by 2K. This is the final expression for the half-life of a zero order reaction. Okay. Now, what will be the equation for first order reactions? For the first order reactions, when T becomes T half, then obviously the concentration of the reactant becomes the concentration of the reactant at 0 time divided by T. That means concentration of R naught divided by T. Now, as we know, the equation of first order reaction equal T equal to 2. K equal to 2.303 by T log of concentration of R naught by concentration of R. Now, if we substitute the value, if I substitute T by T half and R, concentration of R by concentration of R naught divided by 2, then we get this one, K equal to 2.303 by T half log of concentration of R naught by concentration of R naught divided by 2. This one cancel, becomes 2 log 2. K equal to 2.303 divided by T half equal to into log 2. Then T half becomes 2.303 divided by K into log 2. If you just multiply the value of log 2 and 2.303, we will get 0.693 divided by K, which is equal to T half. And this is the main equation for the T half, that means half-life of the first order reaction. Okay. Next we'll discuss what is the unit of rate constant for the first order and zero order reactions. Okay, unit of rate constant. Unit of rate constant for the zero order reactions is mole per liter second inverse. Mole per liter second inverse. As we know, mole per liter is the concentration, S is the time. Okay, concentration by time, that means dx by dt, concentration by time. But for the first order reaction, it will becomes only time inverse. How? See, as you know, the equation of rate constant of a first order reaction equal to K equal to 1 by T into 2.303 log of concentration of R naught divided by concentration of R. Now see, both of these is nothing but the concentration, no? That means the unit remains same. Suppose we have taken concentration is mole per liter. This one also mole per liter. Then mole per liter should be cancelled. That means it becomes log of 0, and log 0 means what? Log 0 means 1. Log 0 means 1. That means in the sense of constant, the k becomes 2.303 by t. T is the time. No extra concentrations, no extra term is there. That's why k becomes proportional to 1 by t, no? 1 by t, and t is the time. T, if we just take the unit of t, then it becomes 1 by second. If I take the second of the unit of 10, then it becomes 1 by second equal to second inverse. That's why I'm written here. The unit of rate constant for fast order reaction is time inverse or second inverse. Okay. Now some of the important characteristics of fast order reactions. Okay. This is very important. Okay. Now first characteristic is the unit of rate constant for fast order reaction is independent on the concentrations. See, if you see the unit of rate constant, that is independent of any concentration. That means there is no concept about the concentrations. Only there is time. That means the unit of rate constant for fast order reactions independent of concentration but dependent on time. Okay, time. It's written. Second thing, the half-life period of fast order reaction is a constant, is equal to 0.693 by k. Since 693 is a constant, that means a digit number, no? A number. Another thing, k is also a rate constant. Now, the third and the most important characteristics of fast order reaction is the fast order reactions never complete. The reaction may come in this way also, that proof that a fast order reactions take infinite time to complete. That means it's never complete. Now see, as we know, T of fast order reaction is 2.303 by k log of concentration of R naught divided by concentration of R. Now let us assume that the reaction is completed at time t. Then obviously the concentration of the reactant becomes 0, no? That means the concentration of the reactant is converted to the product. That means concentration of the reactant becomes 0. Okay, concentration of the reactant becomes 0. Now if we put this concentration is 0 in place of this equation, we get T equal to 2.303 by k log of concentration of R naught by 0, and anything is divided by 0 is infinity, no? Infinity. That's why this term becomes infinity, log of infinity, and log of infinity is nothing but another infinity. Okay, T equal to 2.303 into log infinity implies or T equal to 2.303 into infinity divided by k, and this is also a constant. This is a constant. This infinity means this is another constant. If we just put all the values, then we will get then infinity value. Infinite value means, see, t is infinite, no? T becomes infinite. That means t infinite. That's why I'm saying the fast order reactions take infinite time for completion. If it is take completion for infinite time, then obviously the reaction will never complete. Okay. Now what is the example? Here is the example. Example when a radium, radium which has molecular mass of 226 and the atomic number is 88 reacts. Okay, it produced helium plus what? Rn. Okay, Rn which is the molecular mass, atomic mass 222, that means 222, and atomic number is 86. And this type of reaction is known as nuclear reaction. Nuclear reactions. Okay, this type of reactions never complete. Okay, next, pseudo fast order reactions. Pseudo means what? Pseudo means it it seems to be different but it appears indifferent. Okay, this is the meaning of pseudo. दिखता कुछ और है लेकिन होता कुछ और है, यही है pseudo means. Okay, what is the definition? The reaction which appears to be second order, okay, but actually are the first order are called pseudo first order reaction. That means हम अगर देखें एक रिएक्शन तो होना चाहिए सेकेंड ऑर्डर, लेकिन एक्चुअली प्रैक्टिकली होता है फास्ट ऑर्डर. उसी टाइप का रिएक्शन का नाम है pseudo fast order reaction. Okay, let us take an example of hydrolysis of ester. When ethyl acetoacid, ethyl acetate hydrolysis in presence of acid, it produced ethanoic acid and ethanoic acid and ethanol. Ethanoic acid and ethanol. That means if you see the clearly, no, two reactant molecule is there. Two reactant molecule. That's why the theoretical concept said the reaction rate, that means R, should be K concentration of ethyl acetate into concentration of water. But actually the concentration of water does not changes throughout the reaction. That's why it is taken as constant, and the reaction becomes, it is constant, no, constant into constant is another constant K1, and it becomes R equal to K1 concentration of CH3 COO C2H5. That means ethyl acetate, which is a first order reaction. Okay, second example is the inversion of cane sugar. Same thing. This one is cane sugar C12H22 oxygen 11 react with water in presence of acid, produced glucose and fructose. Remember, glucose and fructose has similar chemical formula, but their structural arrangement is little bit different. And the reaction rate is given by R equal to K concentration of this cane sugar. Okay. In our next class, that means tomorrow, we will discuss about the some question answers. Okay. So just prepare the whole the concept. Next day we will discuss about some question answers. Okay, thank you.